Okay, in chapter section 5.2, we begin by talking about polygons. So the definition we'll use is a polygon is a surface with three or more sides. And if we're working on the same plane, like a sheet of paper or something, the start and end points are the same. So we have a number of polygons here. Let's see, start out with triangle. We'll go from lowest number of sides to highest. Triangle has three sides. 1, 2, 3. So you could draw this from one start point, and when you finish, you come back to the same point you started at. Say if you started right here. Okay. Quadrilateral. That's a four-sided object. Not necessarily square, not necessarily a rectangle. None of the sides are necessarily parallel, but this is a three-sided, this is a four-sided. Talk about a pentagon. Building that houses our Department of Defense is in the shape of a pentagon. But I'm going to draw this pentagon with an unusual number of sides. So we have 1, 2, 3, 4, 5 sides. Pentagon. Hexagon has 6 sides. And I think that's all we're going to talk about here. If you're called on to draw something with more sides, 1, 2, 3, 4, 5, and then 6 here. More than 6 sides, you'll have to go maybe to the internet and look it up, possibly what the name is. So a convention we can use when we're drawing these things. Suppose I have quadrilateral here. 1, 2, 3, and 4. These points here, which I'm going to label A, B, C, and D, these are the vertexes. There's 4 of them in a quadrilateral. And then we will have angles between these sides. And those angles we'll want to sometimes call them out and write about them. So that angle I might call angle A, or sometimes what you'll do to make it even more specific, you'll say angle DAB, and notice that the A is the center here of the angle. But this indicates the angle when we talk about angles. So it's similar to like if we had line segments. And recall, if the angles are the same, we could call them congruent angles. So when we talk about angles, we often talk in terms of degrees. So say angle A equals 95 degrees. So it's a little larger than a 90-degree angle. So we could draw an angle inside of a circle. This will help us understand how we develop these sorts of things. So suppose I do my 95-degree angle and I draw it inside this circle. It's going to look something like this. So if we were to spin all the way around this circle and all the way back to the start line again, this actually takes up 360 degrees. So the reason that is because we have decided to break our circles up into 360 segments. And that dates back thousands of years. The ancient Sumerians and Babylonians used to use these sorts of measurements in their geometry, I guess. So all circles can be broken down. We can, it's just an arbitrary idea that we've decided to say we're going to break it down into 360 individual pieces. But that's what we do. This is so hard to set up here. But there are other ways of looking at segmenting a circle. One thing we can do with a circle is we can define the radius. So we take a straight line, and that line is supposed to be straight, and we can draw it from the center of the circle, let's call it C, to the outside edge, the perimeter of the circle, P. So we could draw a line, and that's the radius of the circle. Now here's something that's interesting, and the Greeks at least knew this, if not even the Babylonians, that I could say I had a string that was as long as this radius R, and I put it along the outside edge of this circle. So this has a distance of R. Well, that's one length, and then I did it again, and I got two of those lengths, and I did it one more time, and every circle three of those R lengths. So I have 1, 2, 3 of those R lengths, and then there's a little piece left over that's not quite as long as R. It's about 0.141 times R. So it's between 1 and 2/10 distance of R. Well, the Greeks recognized that every circle, no matter what size this radius was, it could be 50, it could be 100, it could be 100 miles. You could always stretch that distance, R, around the outside edge in this many times, 3.141 times. Well, this number turns out to be an irrational number, and it actually, the digits keep going on forever, and most of you possibly recognize this at this point, but this number, we call it the symbol pi to represent all those digits. Instead of writing as many digits as we possibly could write, we just write the value pi down here. So this is pi times R, and this equals 1/2 the circumference of a circle. So therefore, we've just kind of shown that the circumference, I'll write the whole thing out now, the circumference of a circle, if this is 1/2 of it, is twice this. So the circumference of a circle equals 2 pi r. So further, we often will say there are 2 pi radians in a full circle. So that's another way to break down the segmentation of a circle. Okay, so let's go back and talk about angles between lines again. So suppose I have a line here and I shoot, I guess what you'd call a ray off of it in this way. So I have a straight line and then I have it intersected by another line that touches here. So this will make an angle A, and this will make an angle, say, B. Well, since we know that this whole angle here for a straight line is half a circle, which is 180 degrees, which is the same thing as pi radians. If I'm given A, if I know angle A, I can add it to angle B, and I will end up with 180 degrees. So I could find angle A if I knew angle B and not angle A by just taking 180 degrees and subtracting off angle B. So let's say that angle A here is 35 degrees. What is the value of angle B? Well, angle B equals 180 degrees minus 35 degrees equals 145 degrees. So suppose I have 2 parallel lines, and then I take another line here, a separate line, and I cut across it somehow, like that. Well, we're going to get a couple angles created. We've got this angle. Let's call it a number now. Now I'll stick with letters. We've got this angle A, maybe this angle B, this angle C, and this angle D. Well, we can notice some interesting things. First off, if this is 180 degrees again here, then we know that, for example, angle B plus angle A equals 180 degrees. So if we know one, we can find another. But there's another thing we can pick up from this diagram here. We can see that angle A equals angle C. And angle B equals angle D. And if we add all these together, they're 360 degrees. If we add angle A plus B plus C plus D, it's 360 degrees. But further, we can extend this. Angle A also equals angle E. And then if you know what this is, using the same idea up here, you could figure out all these other angles. And that's actually all I have time for in this video. You might want to go do that. Try that out.